Hello friends, in this video I am going to explain in detail about redox reactions. So let's get started. What is meant by redox? The word red stands for reduction and the word OX stands for oxidation. When this reduction and oxidation occurs simultaneously. So when reduction and oxidation occur simultaneously, then it is called as redox reaction. Redox reactions. So first we are going to learn what is oxidation and reduction. So first we are going to learn the definition of oxidation and reduction, and then we will see the reason why oxidation and reduction occurs simultaneously. So only when you know the correct definition of oxidation and reduction, you know why it always occurs simultaneously. So first let us see what is oxidation. So oxidation is one of the chemical reaction. As we see many chemical changes in our day-to-day life, one of the chemical changes is oxidation. So if you see our Earth's atmosphere, it consists of different gases. The first abundant gas is dinitrogen, N2, which is present approximately 78% in our Earth's atmosphere. But this N2 is less reactive. It is chemically inert because of its high bond dissociation energy. It is having high bond dissociation energy. Why it is having high bond dissociation energy? Because dinitrogen exists as N triple bond N. Due to the presence of triple bond, it is having high bond dissociation energy. So this N2 is less reactive. The next abundant gas is dioxygen, O2, which is present approximately 21% in our Earth's atmosphere. So this dioxygen is highly reactive. It is highly reactive that it reacts with almost all the elements present in the periodic table. This is the reason why most of the metals exist in their oxide forms in their ores. For example, if you take iron, iron exists as hematite, that is Fe2O3, or magnetite. So these are the iron ores, that is Fe3O4. Then aluminium. Aluminium exists as bauxite, Al2O3. Then if you take titanium, titanium exists as rutile, TiO2. So oxygen reacts with almost all the elements and especially metals. So there is addition of oxygen in almost all the elements. So this addition of oxygen is a separate chemical reaction. So it is studied as a separate chemical reaction, and that is called as oxidation. So now we define oxidation as addition of oxygen. So you see this table, we saw what is oxidation. It is addition of oxygen. For example, if you take rusting of iron, which is the formation of an oxide layer, in iron, oxygen gets added to form iron oxide, Fe2O3. So if you balance this reaction, you will get 4Fe plus 3O2 gives 2Fe2O3. So if you see this reaction, for the metal, there is an addition of oxygen. So this metal is oxidized. So addition of oxygen is a separate chemical reaction. In that similar way, removal of oxygen is also considered as a separate chemical reaction, and that is given the name reduction. So what is reduction? Reduction is the removal of oxygen from a compound. So let us take again iron oxide, and we are adding carbon monoxide in this. So here the oxygen from the compound is removed. So we are getting the metal again, and CO is converted to CO2. So if you balance this equation, you will get. So here oxygen is removed from the metal. So this whole compound is said to be reduced. So I hope you understood the first definition of oxidation and reduction. Now we will go to the second definition. So we saw reduction is removal of oxygen. So this process of removal of oxygen is considered as a separate reaction. Now there is an element which helps in this removal of oxygen. So for the removal of oxygen, hydrogen is used. Hydrogen is a very good reducing agent. So hydrogen is considered as an element which is helpful in the process of removal of oxygen. So removal of oxygen by using hydrogen. Let us see an example. Copper oxide, when it is reacted with the H2, oxygen from the copper is removed. So here we are adding H2. So that is helping for the removal of oxygen. So here you will get the metal copper and then H2 is converted to H2O. So the first definition of reduction is removal of oxygen, and for the removal of oxygen, hydrogen is used in some cases. So we are having another definition of reduction as addition of hydrogen. So what is the opposite of addition of hydrogen? It is the removal of hydrogen. So this removal of hydrogen is considered as oxidation. For that we can see the example of combustion of methane. Methane, when it reacts with the oxygen, it is converted to carbon dioxide and water. So in this reaction, clearly you can see oxygen is added to the compound. So for this compound, it is oxidation. So methane is oxidized. But if you see methane, another one reaction is also taking place, that is hydrogen is removed. So removal of hydrogen is oxidation. So these are the basic definition of oxidation and reduction. Oxidation is addition of oxygen, removal of hydrogen. Reduction is removal of oxygen, addition of hydrogen. So these are the basic definition. Now we will see the other definitions also. See this equation, H2S plus Cl2 gives 2HCl plus S. See the first compound, H2S. So let us see the sulfur atom. Hydrogen sulfide is converted to sulfur. So clearly we can see there is removal of hydrogen. So here removal of hydrogen takes place. So let us see the previous definition. What is removal of hydrogen? Removal of hydrogen is oxidation. So clearly we can say for this first compound H2S, oxidation happens. So for the element sulfur, hydrogen is removed. So removal of hydrogen leads to oxidation in first compound. Now you see the element hydrogen itself. What happens to hydrogen? So if you see hydrogen, hydrogen from this compound is converted to HCl, hydrogen chloride. So already we told that the first compound is oxidized. For the first compound, oxidation takes place. But what is oxidation? Oxidation is addition of oxygen. But if you see this reaction, for hydrogen, there is no addition of oxygen. Instead, chlorine is added. So already we told oxidation is addition of oxygen, but here there is addition of chlorine. So we know only two definitions for oxidation, but here there is a need to write another definition for oxidation, because here oxygen is not at all involved, but clearly the first compound is oxidized, because we know that removal of hydrogen is oxidation. Then how to rewrite addition of chlorine? So we know the similarity between oxygen and chlorine. Both these elements are electronegative elements. So both these elements are electronegative elements. So here instead of writing addition of chlorine, we can write addition of electronegative element. So now we are having the next definition of oxidation, that is addition of electronegative element. Now we will go to the next equation. FeCl3 plus H2. For the first compound, hydrogen is added. So what is addition of hydrogen? Addition of hydrogen, it is clearly reduction. So the first compound is reduced. So now let us compare the reactant side and the product side. FeCl3 is converted to FeCl2. FeCl3 already we told it is reduction. Why it is reduction? Because hydrogen is added. So in first definition, addition of hydrogen is reduction. So here addition of hydrogen leads to reduction. But you see the number of chlorine atoms. In the reactant side it is 3. In product side it is 2. So there is one more reaction, one more process that is happening. So in reduction, there is removal of chlorine atom, which we already told it is electronegative atom. So removal of electronegative element leads to reduction. So in previous slide we saw addition of electronegative element leads to oxidation. Then removal of electronegative element leads to reduction. So these are the next definition of oxidation and reduction. So the first definition is addition of oxygen, removal of oxygen, and with respect to hydrogen. Then now we saw the third definition, addition of electronegative element is oxidation and removal of electronegative element is reduction. Now with respect to electropositive element also we can define oxidation and reduction. So the fourth definition is removal of electropositive element is oxidation. See the example, 2Ki plus H2O2 gives 2KOH plus I2. First compound Ki, in which potassium is added with the oxygen. So what is addition of oxygen? Obviously it is oxidation. So for potassium, clearly we can say there is addition of oxygen, so it is oxidation. So here a hydrogen is also added, but you have to see the more electronegative element. So first oxygen, so this is actually OH minus. So it is a electronegative element, electronegative, so the negative species. So it is oxidation. So now you see iodine. What happens to iodine? For iodine, potassium is removed and it is converted to I2. So what is potassium? Potassium is a electropositive element. So when an electropositive element is removed, then also it is called as what? It is called as oxidation. So this is the fourth definition of oxidation. Now see reduction. The fourth definition of reduction is addition of electropositive element. So see the equation, 3Fe3O4 plus 8Al gives 9Fe plus 4Al2O3. So the metal oxide is converted to the metal. Removal of oxygen. What is removal of oxygen? It is reduction. Here what is added? An electropositive element is added. Aluminium is a metal. Metals are electropositive. So electropositive element is added. So for reduction, addition of electropositive element is also happening. So the fourth definition of reduction is addition of electropositive element. I hope you understood up to this. Let's go to the next concept. Now let us see an equation. 2Na plus H2 gives 2NaH. If you see this reaction, for sodium, hydrogen is added. What is addition of hydrogen? Addition of hydrogen is reduction. So we can say for sodium, it is reduction. Now you see hydrogen. For hydrogen, sodium is added. What is sodium? Sodium is a electropositive element. So here addition of electropositive element takes place. What is addition of electropositive element? It is reduction. So for sodium, when sodium is added to hydrogen, then for hydrogen also it is reduction. So is it possible? No. So here you have to remember one thing. So in a reaction, one substance gets oxidized and the other substance gets reduced. Always oxidation and reduction takes place simultaneously. We are going to see the reason for that now. So clearly for sodium and hydrogen, for both of them, it is not reduction. So there is a mistake in this concept. Still, this concept needs some definition. So we are going to see that with the example of another equation. So let us go to the other equation. Let us see the other example. Instead of H2, we are taking Cl2. So 2Na plus Cl2 gives 2NaCl. Let us take this example and see what is actually oxidation and reduction. So, for sodium, an electronegative element is added. So, what is addition of electronegative element? Addition of electronegative element. It is oxidation. So, sodium undergoes oxidation. Now, if you see chlorine, for chlorine, sodium is added. What is sodium? Sodium is an electropositive element. So, for chlorine, addition of electropositive element happens, and this is called as reduction. So, clearly we can tell sodium undergoes oxidation, chlorine undergoes reduction. So, for this equation, we are clear with the reactions. But what actually happens in oxidation and reduction? We are going to decode that. So, for that, you have to take the product. So, the product is sodium chloride, which is a ionic compound. So, ionic compound consists of what? It consists of ions. So, this NaCl consists of Na plus ions and Cl minus ions. So, what actually happens? Now, we are going to divide this equation into two half equations. So, let us take sodium separately and chlorine separately. Now, if you see the reactant side, in reactant side, we are having sodium, and in product side, we are having sodium ion, Na plus, which is a cation. So, in the reactant side, when we are taking the atomic sodium, the atomic number of sodium is 11. The electronic configuration is 2, 8, 1. So, to attain stability, sodium loses the 1 electron from its valence shell and it is converted to the cation. So, by the loss of 1 electron, sodium is converted to cation. So, how it is converted to cation? By the loss of 1 electron. So, in cation, it is having the stable configuration 2, 8. So, this is what happening in this reaction. Now, if you see the reaction, the reactant side is having 2 sodium atoms. So, 2 sodium atoms are converted to 2 sodium cation and by the loss of 2 electrons. So, this is the whole balanced equation. So, in sodium, what is happening? Sodium loses electron. So, there is loss of electron. Now, let us see chlorine. So, in reactant side, we are having Cl2 and in product side, we are having chlorine anion, Cl minus. So, to balance this in the reactant and product side, in reactant we are having 2 chlorine atoms and in product we are having only 1. So, we have to write 2 Cl minus. So, now if you see the atomic number of chlorine, it is 17. So, the electronic configuration is 2, 8, 7. So, to attain stability, what chlorine has to do? It has to gain 1 electron. So, gain of electron should take place. 2 chlorine atoms are there, no? So, gain of 2 electrons takes place in this reaction. So, as there is gain of electron, there is a formation of anion. So, now in product side, you are getting anion, which is having the electronic configuration 2, 8, 8. So, in both the cases, stability is attained. So, in both the cases, in order to attain stability, some reaction is taking place. In case of sodium, it is loss of electron. In case of chlorine, it is gain of electron. Now, let us compare this with the redox reaction. So, if you take sodium, what is happening? Oxidation happens. But actually, what sodium is doing? Sodium undergoes loss of electron. So, we can compare this with the definition of oxidation. So, we already defined oxidation as addition of electronegative element. Now, we are having a new definition of oxidation, that is loss of electron. Now, you go to chlorine. In chlorine, what is happening? Gain of electron. So, already we have written for chlorine addition of electropositive element, that is reduction. But what actually chlorine is doing? It is gain of electrons. So, now we are going to compare this with the definition of reduction. So, what is reduction? Addition of electropositive elements, and the new definition is gain of electrons. So, now we understood why oxidation and reduction always takes place simultaneously. So I think you know the reason. So what is oxidation? Oxidation is loss of electron. Reduction is gain of electron. So only when an atom is ready to lose the electron, another atom can gain the electron. Or you can also say only when there is an atom ready to gain the electron, an atom can lose its electron. So both these processes should take place simultaneously. When an atom loses the electron, the other atom should gain the electron. When an atom is ready to gain the electron, an atom loses its electron. So this is the next definition of oxidation and reduction. Now let us compare this definition with the previous equation. Now let us see the previous equation. So in this equation, see the product sodium hydride NaH, which is again an ionic compound. So in this ionic compound, you are having the ions Na plus and H minus. So let us see the half reactions. So for sodium, it is the same reaction. Sodium loses its electron to attain stability. Two sodium atoms are there. So 2 Na gives 2 Na plus 2 electrons. So for sodium, it is loss of electron. Now let us see hydrogen. H2 is converted to what? H minus. So first balance this equation. 2H2. H2 gives 2H minus. So how an atom is converted to its anion? By the gain of electron. So let us see the atomic number of hydrogen. Atomic number of hydrogen is 1. So when it gains one more electron, it will have the atomic number, it will have the number of electrons as 2. So according to the duplet rule, when the K shell is having 2 electrons, K shell is having 2 electrons, then the ion becomes stable. So here 2 hydrogen atoms gains 2 electrons to become stable. So in case of sodium, it is loss of electron. What is loss of electron? We already saw loss of electron is oxidation. And in case of H2, it is gain of electron. What is gain of electron? Gain of electron is reduction. So in this equation, just like that, we cannot tell that hydrogen is added to sodium. So sodium is reduced. We cannot tell that because here sodium is oxidized. Oxidation takes place for sodium. So I hope you understood this. So the final definition for oxidation and reduction. So up to this, what are the definitions we saw? Addition of oxygen, removal of hydrogen, addition of electronegative element, removal of electropositive element. Then the final definition which we saw now for oxidation is loss of electron. Then for reduction, the definition we saw now is gain of electron. I hope you understood up to this. Now let us see the concept of oxidizing agent and reducing agent. By taking the same example, 2Na plus Cl2 gives 2NaCl. We already saw that for sodium, oxidation takes place. For sodium, oxidation takes place. What is oxidation? It is loss of electron. Now, the lost electron is gained by whom? It is gained by chlorine. So chlorine is helping for the loss of electron. So chlorine is acting as an agent in this case. So chlorine is called as the oxidizing agent. Chlorine is helping for the loss of electron. So the name for that agent is oxidizing agent. Now, if you see the reaction happening with the chlorine, for chlorine, we saw that it is reduction. So for chlorine, we saw that reduction takes place. So how we can compare that with the oxidizing agent? Chlorine acts as an oxidizing agent and an oxidizing agent is itself reduced, or you can say an oxidizing agent undergoes reduction. So for sodium, for the oxidation of sodium, oxidizing agent is needed. And an oxidizing agent undergoes what? It undergoes reduction. Now, you may think that what happens in reduction? So, what is reduction? Reduction is gain of electron. So, how electron is gained? Only when a substance loses its electron, another substance can gain the electron. So, for the process of reduction, another substance has to lose its electron. So, in this case, the substance sodium acts as a reducing agent. So, here for the reduction, that is for the gain of electron of chlorine, another substance is acting as reducing agent. Now, what is happening to a reducing agent? A reducing agent undergoes oxidation. A reducing agent itself undergoes oxidation. So, it is a cyclic process. So, it happens simultaneously. So, a substance to get oxidized, an oxidizing agent should be present. An oxidizing agent itself undergoes reduction. So, for a substance to get reduced, a reducing agent should be present. A reducing agent undergoes oxidation. So, everything happens simultaneously. So, this is the reason why always oxidation and reduction occurs simultaneously, because for the loss of electron, another substance has to gain that electron. For the gain of electron, another substance has to lose the electron. So, oxidation and reduction always occurs simultaneously, and this is what we call as redox reactions. So, I hope you understood up to this. Now, we are going to learn about oxidation number. So, up to this, we saw the definition of oxidation and reduction. So, we saw the different definitions of oxidation and reduction. So, last recent definition which we saw is loss of electron for oxidation and gain of electron for reduction. Now, I want a numerical representation. Numerical representation for the process of oxidation and reduction. So, I will explain you with a simple example. So, if I say, or if I write Na plus, what will you understand? Sodium has lost its electron. So, clearly we can write loss of one electron took place. If I write Mg2 plus, then what will you understand? It is loss of 2 electrons. If I write Al3 plus, then what will you understand? You will understand it is loss of 3 electron. So, here which is helping you to understand the number of electrons? It is the charge. The number present in the charge helps you to understand something has happened. So, now this is called as the numerical representation of the reaction. So, here the reaction is loss of electron. But how many electrons? For sodium, it is loss of 1 electron. Why? Because Na plus, Mg2 plus, loss of 2 electrons, Al3 plus, loss of 3 electrons. So, this is a numerical representation. So, these are ions. So, easily you can understand. But take the compound H2O, water molecule. Water molecule is formed by what? It is formed by covalent bonding. How is a covalent bond formed? It is formed by sharing of electrons. When I write NaCl, you can clearly write it is Na plus, Cl minus. What is Na plus? Na plus is loss of electron. What is Cl minus? Cl minus is formed by the gain of electron. But in case of water molecule, there is no formation of ions because it is sharing of electron. Now, if you see in detail, the structure of water molecule is a bent structure. So, 2 covalent bonds are there. How a covalent bond is formed? Hydrogen share 1 electron, oxygen share another electron. But here the question is whether the electron is present in between the 2 atoms. The electron pair is not present in between the two atoms. The electron pair always move towards the more electronegative element. We know that the electronegativity of oxygen is greater than hydrogen. So, the electron pair moves towards the oxygen. What happens now? As the electron pair is negatively charged, and it moves towards oxygen. Oxygen develops partial negative charge. And this electron pair is now away from hydrogen, no? So hydrogen develops partial positive charge. So I need to represent this process also. So as I already told, in an ionic compound, it is easy to write Na plus Cl minus. But what about covalent compound? For a covalent compound also, there is a partial development of charge. For oxygen, it is delta minus. For hydrogen, it is delta plus. I need to represent them. So for that only, we are using the oxidation number. So oxidation number denotes the state of an element in a compound. So it is based that electron pair in a covalent bond belongs entirely to more electronegative element. Now I need to represent this with a number. So it is a numerical representation. Also, there is one more use with this oxidation number. So if you take CuCl and CuCl2, copper forms two different types of compounds with the chlorine. Can I write the name of both the compounds as copper chloride? It is not correct because there is a difference between these two compounds. So in first compound, copper is bonded with only one chlorine atom. In the second compound, it is bonded with the two chlorine atoms. I need to differentiate them. So for that also, we are going to study the oxidation number. So there are a set of rules for the oxidation number. So let us see that. The first rule of oxidation number is, in elements in the free or uncombined state, each atom bears an oxidation number of 0. So see the difference between sodium and the sodium ion. Already we told Na plus is a cation. It is having a charge. But what about Na? It doesn't have a charge. How to represent that? When it is an anion, I can write negative sign. When it is a cation, I can write positive sign. When it is neutral, you have to represent that by 0. So for an element in its free state or uncombined state, the oxidation number is 0. In same way, if I write Mg, it is 0. Then what about Cl2? Two chlorine atoms are combined, but there is no charge. It is a neutral compound. So the oxidation number is 0. Then H2O2, the oxidation number is 0. Then you can write Al, so and so on. So when an element or a molecule present in their uncombined state, so always chlorine exists as Cl2, always hydrogen exists as H2, then oxygen exists as O2. So it is their uncombined state. You cannot see Cl alone. Always it exists as Cl2. Same as H2O2, N2. So in all these elements or molecule, the oxidation number is 0. The next rule is, for ions composed of only one atom, the oxidation number is equal to charge of the ion. So it is monoatomic ion. So already we saw the example Na plus, Mg2 plus, Al3 plus. So these are the monoatomic ions. Now what is the oxidation number? The oxidation number is equal to charge of the ion. So what is the charge of sodium? It is plus. So the oxidation number is plus 1. What is the charge of Mg? It is 2 plus. So the oxidation number is plus 2. For Al3 plus, it is plus 3. Then when we go to Cl minus, the charge is minus. So the oxidation number is minus 1. O2 minus, the charge is 2 minus. So the oxidation number is also minus 2. So in this way, for a monoatomic ion, when the charge is mentioned, then the oxidation number is equal to the charge of the ion. The algebraic sum of the oxidation number of all the atoms in a compound must be 0. Let us take the example of sodium chloride. It consists of Na plus ions and Cl minus ions. So the oxidation number will be equal to, for sodium, so it is Na plus. So the oxidation number is equal to charge. So it is plus 1. And for chlorine, the oxidation number is minus 1. So here we are talking about algebraic sum. So when you add this, the algebraic sum must be equal to 0. So when you add the oxidation number of all the elements present in a compound, the sum must be equal to 0. So for NaCl, plus 1 minus 1 it is equal to 0. Let us see the next example, MgCl2. So we know magnesium loses 2 electrons because it is having the atomic number 12, 2, 8, 2. So if it loses 2 electrons, it will attain stability. So it is Mg2 plus. Then again chlorine, it will become an anion by gaining 1 electron. 2 chlorine atoms are there. So now the sum of the oxidation number will be equal to 0. So let us check that. For magnesium it is plus 2. Then for chlorine, 2 atoms are there. So 2 into the charge is minus. So minus 1. Now when you add this, it should be equal to what? 0. So you can clearly see it is equal to 0 only. So the next rule is the algebraic sum of the oxidation number must always be equal to 0. Next, the oxidation number of hydrogen is plus 1 except when it is bonded to metals in binary compounds. So the fourth rule is very important. All the rules are important only, but the fourth rule. So always the oxidation number in most of the cases for hydrogen is plus 1. But when hydrogen is bonded to more electropositive element like sodium, potassium, lithium. So in this case, it forms the binary compounds with this electropositive metals. So in that case, hydrogen will be having the oxidation number of minus 1. So only in this compounds like sodium, lithium, potassium, only when it is bonded to metals, more electropositive metal, then hydrogen will be having the oxidation number of minus 1. Otherwise, it will have the oxidation number of plus 1. So I hope you understood this. Next rule is the oxidation number of oxygen in most compounds is minus 2. So this fifth rule is also important. So you see the atomic number of oxygen is 8. The electronic configuration is 2, 6. So it has to gain 2 electrons to attain stability. So in most of the compounds, oxygen always try to gain 2 electrons. So it will become O2 minus. So in most of the compounds, oxygen will have the oxidation number as minus 2. However, we come across 2 exceptions. So the exception is in peroxides. In peroxides, for example, you can take hydrogen peroxide. So if you find the oxidation number of oxygen, we already saw in the previous rule, the oxidation number of hydrogen is plus 1. So let us substitute the value for hydrogen. 2 hydrogen atoms are there. So 2 into plus 1 plus, we don't know for oxygen. Let us find that. So you have to write it as X. 2 oxygen atoms are there. So it is 2X. And we know that the algebraic sum is always equal to what? It is 0. So when you equate it to 0, what will you get? 2 plus 2x equal to 0. 2x is equal to minus 2. Then the value of x is minus 1. So in peroxides, the oxidation state of oxygen is minus 1. In most of the compounds, it is minus 2. But in peroxides, it is minus 1. Then if you see superoxides, for example, let us take the compound KO2, potassium superoxide. Now let us find the oxidation state of oxygen. So potassium is a group 1 element. So it is similar to sodium. The electronic configuration is similar to sodium. So it loses 1 electron. So the oxidation state of potassium is plus 1 plus 2x equal to what? 0. So 2x is equal to minus 1. So the value of x is minus 1 by 2. So here the oxidation state of oxygen is minus 1 by 2. So in both the cases, why there is a difference in the oxidation state of oxygen? So in first case, 2 oxygen atoms are there. Each oxygen atom gains 1 electron. So only each oxygen atom is having the oxidation number of minus 1. In second case also, both the oxygen atom gains 1 electron. So both the oxygen atom gains 1 electron. Then for 1 oxygen atom, it will be equal to what? Half electron. So it gains of half electron. So actually both the oxygen atoms are first bonded together then from their molecular orbital only they gain 1 electron. So that is why we are getting minus 1 by 2 in KO2. So the next rule is, in all its compounds, fluorine has the oxidation number of minus 1. So it is obvious that fluorine is the most electronegative element. And what is the atomic number of fluorine? It is 9. The electronic configuration is 2, 7. So it will gain 1 electron to become 2, 8. To attain stability, it has to gain 1 electron. And fluorine is the most electronegative element. So it always gains 1 electron. Gain of 1 electron. After that, what it will happen? What it will become? F minus. So the charge is minus and the oxidation state is minus 1. So fluorine always exists in minus 1 oxidation state. Now, with this in mind, find the oxidation state. Find the oxidation state of oxygen in this compound, OF2. In this compound, find the oxidation state of oxygen. So this is also an exception. Exception of oxidation state of oxygen. Why I am telling this as exception is, in most cases it is minus 2 only. But in this compound, the oxidation number of oxygen is not minus 2. So you find the answer and you tell in the comments. So let us see the next rule. So the next rule, 7th rule, it is very simple. The group 1 elements always has the oxidation number of plus 1 and the group 2 elements always have the oxidation number of plus 2. So you have to keep everything in your mind. So let us see from the starting once again. So for a free state element, the oxidation number is 0. So for monoatomic ion, the oxidation number is equal to charge of the ion. Then the algebraic sum of the oxidation number is equal to 0. Then for hydrogen, it is always plus 1. But when hydrogen itself is bonded to another electropositive element like sodium, lithium, potassium, then it will have the oxidation state of minus 1. The oxidation number of oxygen in most of the compounds is minus 2. But there are some exceptions. First exception is peroxide, in which 2 oxygen atoms together they gain 2 electrons. So for each oxygen atom it is minus 1. Then superoxide. So this is called as what? Superoxides. In superoxides, both the oxygen atoms are bonded together, O2. Then together they gain 1 electron. So this is what is present in a superoxide. Both are already bonded together and they have the charge minus 1. Then for one oxygen atom, how will you find? It is just a representation. For one oxygen atom, it will be minus 1 by 2. So from the molecular orbital only, they are gaining 1 electron. Then in all the compounds, fluorine has the oxidation number of minus 1. Then I gave you one homework. You find this oxidation state of oxygen in this compound and you tell in the comments. Then the oxidation state of group 1 elements is plus 1 and for group 2 elements, it is always plus 2. So I hope you understood up to this. Now we saw the concept of oxidation number, and with the concept of oxidation number, we are going to relate oxidation and reduction. Let us take the same example. So we saw for sodium, there is what? There is loss of electrons and oxidation takes place. And for chlorine, there is gain of electrons and the reduction takes place. We saw this. Now we are going to see with the concept of oxidation number. So with the concept of oxidation number, let us see the reactant side. Sodium is present in its elemental free state. So the oxidation number for a free state element is 0. Chlorine also is present in the uncombined state, free state. So the oxidation state of chlorine is also 0. Now we saw that already in the compound sodium chloride, the ions present are Na plus and Cl minus. So for a monoatomic ion, the oxidation state must be equal to the charge of the ion. So here the charge of sodium is plus. So the oxidation state of sodium is plus 1. The charge of chlorine is minus. So the oxidation state of chlorine is minus 1. Now, just you compare the elements in the reactant side and the product side. So, you put an arrow mark. See the oxidation state change in sodium. From 0, it has become +1. From 0 to +1 is increase in oxidation number. See the oxidation number of chlorine. From 0, it has become -1. 0 to -1 is decrease in oxidation number. Already we told that for sodium it is loss of electron, that is oxidation takes place, and for chlorine it is gain of electron, that is reduction takes place. Now we are going to compare that with the concept of oxidation number. Oxidation refers to increase in oxidation number. Reduction refers to decrease in oxidation number. So always when there is an increase in oxidation number, it refers to the process of oxidation. When there is a decrease in oxidation number, it refers to the process of reduction. So this is the final definition of oxidation and reduction, and it is the easiest way to find which element is oxidized and which element is reduced. So let us see all the definitions. So far we saw up to loss of electron and gain of electron for oxidation and reduction respectively. Now what is oxidation? Finally, it is increase in oxidation number is oxidation and decrease in oxidation number is reduction. So I hope you understood this. Thank you.